Can you hear us? Okay, that's one. Well, everyone, we're gonna start. We are going to record this presentation. I hope it is okay with all of you. Yeah, so we're gonna put this online presentation, not online presentation, this recording online. So everyone who could not come, they can still watch this presentation. So my name is Yuni Sari, and I'm here with my colleague, Josh. We are the organizer of the GDG Perth, and today we are welcome our guest, Kaz Sato from Google, and his headquarters is in Japan. So Kaz, are you there?
Sure. Can you hear me?
Yes. Oh, Kaz, can you tell us a bit about you? It's so good to have you back here.
Yeah, this is the second time I'm invited to the GGG Perth, and thank you so much for the invitation. And I'm Kaz. I'm a developer advocate from Google Cloud team based in Tokyo. And I have been working at Google over 10 years. And for the last 6 to 7 years, I have been working as a developer advocate, which is like an evangelist for the developers. And I'm now focusing on the cloud AI products, machine learning AI from Google Cloud.
Oh, yes, I remember that you had a very good presentation and everyone really enjoyed the presentation. Last time when we had the GDG Perth event last time, and you flew straight away from Japan for that one. So
yeah, I remember that was like 2 years ago, right?
Yeah, it's time flies, isn't it? Like it's really good to have you back here. And I was quite, oh well, we could not have anyone from overseas, but then now everything online, and I think everyone can still meet each other through Zoom or Google Meet or something like that. So
Right.
yeah. So what are you going to talk about today?
I'm going to talk about ML ops.
Okay. Well, I will just give the time for you to explain more what you are going to talk about, and it's very exciting. Okay, time is yours,
Thank you.
guys. Yeah.
Okay, so I can take like a 30 to 40 minutes, right?
Yes.
Okay, got it. Thank you. Hi, thank you for taking your time for the session. As I introduced, I'm Kaz, and today I'd like to talk about ML ops on AI platform. It's all about productionizing your machine learning service with for the web services or enterprises. And the thing is, Google has been doing that for many years, almost 20 years, putting the machine learning into the core of the business. And we have been building one of the largest the machine learning production machine learning system, up and running it for like 15 to 20 years. So we are putting those best practices or narratives into actual products and tools. So that's the main topic of this session. So I'd like to quickly introduce how Google has been learning many practices, narratives about operating the machine learning system. And then I will introduce what is AI platform from Google Cloud. And I will talk about how you can build your ML ops platform on AI platform. And actually, there's no workshop for today. This slide is made for a workshop, so it has the workshop. But I will instead show the actual the screen capture of the user interface so that you can get the idea. And then I will discuss about what would be the next challenges after building your pipelines. So MLOps at Google. But this is the actually word I heard from one software engineer at Google. Launching the machine learning system is easy, but operating that machine learning system for many years is the hardest part. By the way, if you have any questions, please feel free to add any questions on the chat window so I can try pick some of them to answer that. So he said the real problems with the ML system. will be found while you are continuously operating it for the long term. And this is a famous diagram quoted from one of those the published paper from Google machine learning teams. And the paper is called Hidden Technical Debt in Machine Learning Systems. It's published in 2015. So now many companies and enterprises have tried out their first or second or third machine learning POC systems by using Jupyter Notebook or writing some Python code with PyTorch or TensorFlow. And maybe they have experienced that machine learning could be applied to solve some of the enterprise challenges or problems. But this is just the beginning if you really want to bring the machine learning into the core part of the IT business. So I'm checking the chat. Okay. Because the machine learning model itself is just a tiny fraction of the whole required systems. You have to require every setup, starting from data collection, serving infrastructure, feature extraction, data verification, monitoring, analysis tools, resource management, everything for making everything as a productionized system. So I sometimes use some metaphor of making a confectionery compared to building a confectionery factory. So in trying out with the Jupyter Notebook for the machine learning POC is just like making some the cookies or some confectionaries by yourself with oven. But the productionizing machine learning is like a building of the factory for production of the confectionaries or cookies for millions of people. So it's a totally different thing, and you will have many different challenges like these. But currently, in many companies or enterprises, the data science and IT are isolated. Only a couple of customers or companies has been successful on merging these two, but in many cases, especially in the POC cases, IT department, IT team doesn't care much about what the data science team is doing, whereas data scientist teams don't know much about what's happening in the productionized machine learning system. So these the phases from POC to production, like ad hoc data analytics, or manual data preparation, model training, etc., and bringing those models into production. So other processes are in many cases isolated. So this is the problem. And this is exactly a very similar situation we had in the web industry like 10 or 15 years ago, where the DevOps practice has not established yet. So there are many challenges for productionizing ML. And it's not so easy compared to the ordinary usual IT systems, because if it's just an ordinary usual IT systems, you can just take a look at the challenges on the right side, like scalability, availability, portability. By using the container technologies or some virtual machines, you have to make everything scalable, like not having just one server. You have to have multiple servers or maybe tens of servers. And things like that. And reproducibility, you don't have to rely on a single data scientist or ops engineer. You have to make everything reproducible by anyone. Modularity, microservices, monitoring, alerting. So these are all the usual productionization challenges. But the hardest part is that those challenges are combined with the machine learning unique challenges, like how do you design the governance of data in the enterprises or teams, or governance of features or models or pipelines or experiments? If it's just on POC phases, you can just let the data scientists do their own experiments on the Jupyter Notebook, and you can just ask those data scientists to reproduce it. But if you want to make it scalable for the production system, you have to have the practice of governance on all those so-called artifacts. We call it artifacts. That includes everything. It's like a data, features, models, pipelines, experiments, everything. So it's artifacts, so-called. And also you have to think about continuous training, not only just clicking the cells on the JIT notebook, you have to automate everything to make it reproducible. And some of you might heard the term called training serving skill. This is a technical term we used at Google that represents the dropped down accuracy when you are deploying the model into the serving system. So while you are training the model, you'll be using some clean, healthy training data with the feature engineered everything. But it sometimes happens that at the serving time or in the production operation, if you run the continuous training pipeline, sometimes the training data could be not healthy or not clean compared to the training time. So all of those changes, or maybe slight changes in the algorithms they have used by the ops engineers for the data preprocessing, or any slightest changes could have the machine learning model accuracy dropped down at the serving time. So this is the skew, training serving skew. Data validation, because data is now the new code for your IT system. So people don't write any program code against machine learning model anymore. Instead, you would prepare and dump those training data into the machine learning system to train the model. And the model defines the behavior of IT system. That means data is just like the program code written by human programmers. So you have to validate the data. Model analysis and the behavior of the model, sometimes defines the requirements for the fairness and explainability. You may want to check if your model's behavior is fair or not for the every possible identity groups, or you have to think about explainability to explain the behavior or the mechanism happening inside the machine learning model to all the stakeholders. So all of those machine learning unique challenges for the machine learning makes the challenges very complicated. So that's the reason why there's some paper published by the Google called it as it's like a high interest rate credit card or technical debt. So some teams don't think machine learning as a silver bullet. Instead, they think machine learning model is just like a credit card with the high interest rate. So that's the hardest part. And we have been publishing the narratives and experience papers since 2015. So now we have a very great word called MLOps. But even before we have the new buzzword called MLOps, we have been building practices, establishing the rules, collecting those narratives and learnings inside Google for over 15 to 20 years for running the large-scale machine learning system. So the narratives are published with those papers. And now Google Cloud team is trying to convert the assets, narratives, and the learnings and best practices into the actual products. So that's the so-called cloud AI and AI platform. And so the MLOps at Google is based on those narratives. And the buzzword called MLOps is just being used in last 3 years. It's all about bringing the DevOps practice into machine learning system. It's all about unifying the data scientists and IT and removing the isolation between them. So it's the MLOps. And in past 1 year or maybe 2 years, people are only focusing on the building a pipeline when they're talking about MLOps. But Google knows that the real problems for the MLOps would be happening after building the pipelines. So we have been building a product called AI Platform to solve those challenges. AI Platform is a a kind of umbrella. And under that big umbrella, we have many different independent components. For example, as an application, you can use the AI platform for the various applications like image recognition or video analysis, building a conversation chatbot with the speech to text or text to speech, or language processing NLP, or you can build a model for the structured data. So those are the applications, and we provide the many different machine learning model with APIs or AutoML technologies that allows you to customize your own model without writing much Python code, with many lines of Python code. So those are the components of the AI platform, and also you can use the many different tools and services as the core component of the AI platform. You can use the Jupyter Notebook running on the Google Cloud instance. You can use the data labeling service. That labeling is actually provided by the human-based operation. And what else? The AutoML technology, the large-scale distributed training, explainable AI tools, or large-scale prediction setup. Those are all available as components under the AI platform. So while you are using these single notebooks, you can easily access those easy-to-use components. So by using the AI platform, you can get the higher productivity compared to the older environments where you would have the independent GPU server installed by yourself, supported by yourself, and it's really hard to be shared with the other engineers or data scientists. And by using the AI platform, you can also introduce the concept of the experiment management rather than trying out many experiments by yourself on the single notebook. And it provides a seamless integration with the other components like AutoML or BigQuery. BigQuery is one of the most popular data warehouse service from Google Cloud. And MLOps is the, of course, main feature you can get with the AI platform. So now, in many companies, the POC, many companies has finished trying out the first POCs for machine learning, and they are now trying to bring the assets from POCs into the production system. Then data scientists, it could be just one of the different roles. In POC, maybe data scientists can cover all the different roles, but in production, you would have the product manager or data analyst, data engineer, data scientist, ML developer, ML engineer, and so on. So you have to build a scalable teams, and that shares some common platform. That is the purpose we design the AI platform. As I mentioned, there's a Jupyter Notebook instance running on Google Cloud. So instead of using your own GPU server or Google Collaboratory, which is the free tool, instead this is a paid service, this is a commercial service. So compared to the Google Colab, you can get the professional technical support, and you can choose to use the much powerful instances. Like at maximum, you can get the 16 A100 NVIDIA GPUs in single instance. And it costs so much, but you can just create that instance just for like 1 hour for training the heavy-weighted CNN task or something, and shut it down. So you don't have to buy the NVIDIA DGX2 or those expensive machines by yourself. You can just use the instance and shut it down. So you can just pay by use. And also, you can choose from the variety of the options for the training and prediction environment. If you want to run the large-scale distributed training with the A100 or B100, you can use the training, AI platform training, which is a large-scale distributed training environment. AutoML allows you to click on some buttons on the user interface, and without writing many Python code, it automates a major part of the feature engineering or the hyperparameter tuning or the model selection or model design on training your own model. and you can choose to use that. And also, BigQuery itself has the simple machine learning training functionality in it. So if you just if your model is a very simple model like a linear regression or logistic regression or just a plain XGBoost tree-based model, then you can, in some cases, you can just train your model on BigQuery without exporting those data into Jupyter Notebook. So there are many options on AI platform. So those are the basics of the AI platform. And now we'll discuss how you can apply the practices of MLOps with those AI platform components. So this is a quotation from the one of those papers from Google. At Google, a hybrid research approach where engineers and researchers are embedded together on the same teams. And this practice has helped reduce the source of friction significantly. So this is talking about the isolation I mentioned in the first part of the session. So instead of having some isolation between the data science and the IT at Google, it's really advised to embed those data scientists, researchers, and ops engineers get together in the same team, sharing those assets and infrastructure. And these are the other quotations from the another paper, Rules of Machine Learning. There are some rules defined. You have to plan to launch and iterate, not only training the single model at once. So for the first time, from the first time, you have to prepare for the retraining the model again and again. And also, you have to understand what's the freshness requirements of your system. So every model could be stale in long term, but that period could change based on the business requirement. So for example, if you're training some, for example, speech to text model or text to speech model, maybe you don't have to retrain the models every week. Maybe you can just train the model every maybe year or maybe every quarter, because the voice recognition model or voice synthesis model wouldn't change so much. But if you're building some recommendation system for the EC side, then maybe for some requirements, maybe you want to retrain the model every day or maybe every 4 hours or every 1 hour, to keep the recommendation system fresh and responsive to the changes of the current situation. So you have to define what's the freshness requirement and what's the period of retraining, running the retraining process of the pipeline. And you have to detect those possible problems inside the machine learning model before pushing that model into the production system. So you have to validate the model behavior, and also you have to validate the training data before start training. So AI platform pipeline is the important component in the AI platform that could be a basis for bringing those practices in the team. So it provides the continuous training and deployment and experiment management tool. As you can see, there will be some flow, the DAG flow, where you can check out the status of each phases in the flow, like data ingestion, data transformation, data validation, training, and evaluation of the model, pushing the model. So those phases are represented by those rectangles, and you can easily check out what's the status and what's the log outputs and what's the visualization outputs from each component, each phases. And as I mentioned, those are called artifacts. Artifacts includes everything, including each data or maybe versions of data. Features could be extracted from the raw data, the models, and pipeline design, and each experiments executed by the data scientists. Those all deliverables are called artifacts, and we provide a tool for provide a reproducibility, auditing, and governance on those artifacts. So reproducibility is one of the important components here. So anyone in the team can reproduce the same model. So sometimes it's really hard to reproduce the high accuracy with the deep learning model, because training the deep learning model doesn't guarantee any, the optimal result. So you have to try out with the different conditions. But if you have some metadata management for tracking the conditions, like hyperparameters, or what was the versions of the data for the training, or what was the feature engineering code you have used, then everything could be much easier to reproduce. And also, those functionalities are implemented as open source tools, like the Kubeflow pipelines and TensorFlow extension, or TFX. So if you have any requirements for customizing the system, for example, some of my customers want to use this AI platform pipeline for orchestrating the machine learning workflow for their on-premise devices or their on-premise network. In that case, maybe you can build some virtual connections between the Google Cloud project and your on-premise network and on-premise devices, so that the AI platform pipeline can control those devices for pushing the models or collecting those training data and so on. Okay, now I got the one question on the chat window. When you train a model every week, how does it influence the DevOps? Yeah, actually that defines maybe the design of the whole MLOps or DevOps, the infrastructure you want to build. So if the business requirements, the business requirements defines that the freshness requirement is much longer time. Like you don't have to retrain the model for a couple of years. Maybe you don't have to spend much cost on building the machine learning pipeline. You can just click the cells and execute the training on the Jupyter notebook, and that's it. But if you have to retrain the model maybe every month or maybe every week, then you definitely want to build on some machine learning pipeline to make everything reproducible and not dependent on a single person. Does that answer to your question?
Yes, thank you. Can I just ask the following question? So basically, for the shorter training period, you require the pipeline. But if it's a longer one, like 1 year or 2 years, pipeline is not very useful. Is that right?
Yeah, that is right. But even for the latter cases, maybe your business stakeholders would want everything reproducible, because it's in many cases data scientists would move to the other companies, and if there's no any way to reproduce the same environment, then the machine learning model could be useful. So other the production system, basically, even if the freshness requirement is not so high, putting everything into the pipeline is not a bad idea for the business continuity.
Okay, thank you for the answer. Thank you very much.
No problem. Okay. So as I mentioned, the tracking all the metadata for the artifacts is the key concept. So, and we provide a lineage explorer user interface where you can easily check out those metadata on each artifacts, like models and the data sets and features extracted from data. And I'll show a quick demonstration of Lineage Explorer at the demonstration part. So this is the whole picture of the machine learning lifecycle management with the AI platform pipelines, starting from the extracting data from data warehouse or maybe storage. And then you may want to apply some validation against data, because sometimes you have the unhealthy data included in the training data set that would be infected to the training model. So you don't want to do that. And you have to do some preparation, feature engineering, pre-processing against data, train the model, evaluate on the model, and validate the model behavior. Sometimes you may want to apply the explainability tools or maybe fairness tools applied in the validation model, so that you can make sure that your model is fair. You can provide some fairness against the major identity groups, and then deploy and push the model into the service. And if you take a look at the bottom of the diagrams, so one of the most powerful features of the AI platform and AI platform pipeline is that it's easily integrated with the other tools from Google Cloud, like BigQuery or the Cloud Dataflow, which is a batch and stream processing framework from Google Cloud. So in many cases, the BigQuery is one of the most powerful tool for data scientists, because it's super fast, data warehouse compared with the other data warehouse from the other cloud vendors. So the tight integration with the other tools is one of the most important part. And AI platform pipelines itself is running on Google Kubernetes engine or just Kubernetes. So it's all based on the container technology. But you don't have to think much about those Kubernetes, Google Kubernetes engine or Kubernetes itself. It's all managed service. So I will show the actual user interface later, but what you have to do actually is just press some buttons to create the cluster for the AI platform pipelines and import some the pipelines definitions, and that's it. So you don't have to hire a cutting edge the Kubernetes container the ops engineers to do so. This is totally managed service. And on top of the AI platform pipelines, you can use the SDK of the open source tools, such as the Kubeflow Pipelines SDK or TFX SDK. Those SDKs provide the tools for introducing the many different the best practices for the MLOps from Google, like the data validation or model analysis. So let's take a look at how the possible use cases of the pipelines. There are some numberings like 1, 2, 3, 4, 5. For example, this is number 1. The AI platform pipelines could be useful for data scientists for their experimentation management. So instead of the arbitrary running the Jupyter notebook on a single person's environment, you can keep tracking all the experiment result. What kind of the data you have used, or what kind of the model you have used, what kind of the pipelines you have used for feature engineering. Everything could be tracked and stored on the metadata database. So the experimentation can be reproducible. And I see some of the data scientists has been using this spreadsheet, like a Google Sheet or Excel, for tracking the experiments. But you can remove those, stop using those spreadsheets for tracking the experiments. The other use cases are, of course, continuous training. So if you want to build the production system, the training continuously is the most important part of the building pipeline. And also, this is a new practice called the model monitoring. Not many machine learning customers are introduced the practice of model monitoring at this time, but at Google, because the machine learning is the like a core part of making money for Google. Google doesn't, make any PR messages against Google Ads and how it works, but actually, as you know, the almost 90% of the benefits, the profits of the Google is coming from Google Ads, and Google has been using machine learning from the start, like almost 20 years. So if there's any unexpected behavior in the core machine learning model in the Google Ads, it can, in an instant, it can easily blow like millions of dollars in a few seconds. And we have experienced that sometimes in the past. So those are the the learnings we have learned in past years with the largest machine learning system. But anyway, the monitoring and making sure your model's behavior is expected is super important part, so that you can bring the practices of the modern management and modern governance. And we provide multiple tools for supporting that practice, like explainability. What if tool is the tool for the explainability or counterfactual analysis. Modern monitoring tool will be launched maybe this May, and so on. And especially another important practice for the model management and governance is the data validation. Because as I mentioned, your behavior of your model is defined by training data. Now the training data is just like the program code you have written for building the IT system. So this is a quotation from one of those papers, GFX paper. We want the user to treat data errors with the same rigor and care that they deal with bugs in code. So if you have any troubles in this, for example, some distribution skews, distribution drift in some features, that could create some unexpected behavior on machine learning model. So it's just like a bug in code. Okay, I got a new message on the chat. Do we need to use all the tools you mentioned before? Or can we choose? Yeah, you can choose, and you don't have to use all the tools. Yeah, we just provide the options. For example, some companies don't have to start using the explainability tools or some the fairness tools, but some large companies may want to use the explainability tools. So it's totally depending on the business requirement. So by introducing the concept of data validation to the Google Play team, the average application install rate of the whole Google Play applications, I don't know how many it is, like billions of the applications on the Google Play. The average install rate have improved 2% after introducing the practice. This is huge impact made with the this practice. So to do so, we provide an open source tool called TensorFlow Data Validation. And also it has the TensorFlow in the on the name of it, but it's actually don't dependent on the TensorFlow itself. It's just a data validation tool for any arbitrary data set. So you can apply this tool for the PyTorch or scikit-learn or any other tools. This is a tool for the understanding and validating the monitor and the training data at scale. So at Google, the many large teams are using these tools for the validating petabytes of data every day. So let's take a look at some demonstration with video. So this is a sample code where executing the SQL to get the sample code. It's a Chicago taxi data set with all the trip start timestamp and end timestamp with the longitude and latitude and so on. And you can easily, by using the TFDB tool, you can easily get the statistics values and their visualization inside the Jupyter notebook. So in this case, you're drilling down into the feature called payment type. So you can easily check out the payment by cash and credit card and no charge or the major the data classes. And also you can visualize some of the distribution changes in the distribution between the different data sets. You are seeing the amber colored bar chart and the blue colored bar chart. So by these represents the variation data set and training data set. So if you see any degradation on the accuracy on the evaluation data set, you can use the TFDB to check out to find out, oh, there's some significant changes on the feature set feature distribution. And also you can do the same thing on the production prediction side. So by setting some threshold on detecting those skews of the distributions, you can easily get some alerting from the production systems when the prediction system is working, it's sometimes it does the sampling on those the distribution of each features used for the serving. And if there's any significant skews detected on any of each features, then you get some alerting from the system. So this is the data validation practices you can apply for the production system. So actually, we don't have the workshop, so instead I'd like to show some user interface. This is the user interface for the AI platform. Now we are in process of unifying everything into the new user interface that is called AI platform unified. But at this time, we have two user interfaces. The AI platform is the older one, and the AI platform unified is the newer one, which unifies everything like AutoML or the APIs and pipelines everything into a new one. And if you have been using if you have been using the existing tools, then you can keep using the older user interface. But anyway, you can choose the AI platform pipelines and press some buttons to open the AI platform pipelines user interface. Actually, it's a user interface of the Kubeflow pipelines. As I mentioned, the AI platform pipelines runs the open source tool for the Kubeflow pipelines, and it has the console like this. And you can easily choose the any one of the pipeline designs. These are all the pipeline designs, so you can choose, for example, this one of them. Anyway, you can choose to any one of the pipelines and execute experiment. So after executing with any one of those experiments, then you can check out the result of the those so-called runs. We call it as run. So take a look at the one of those experiments. Then you can watch out. So it's the data flow diagram like this one. So this is a very simple hello world kind of the pipeline design executed on the pipelines that takes the text lines and splitting the text line and print into the log console, and clicking one of the those the rectangles, all the outputs, input and outputs. For example, with this component, the outputs are like this: 2, 4, 6, 8, 10, 1, 3, 5, 7, 9. So it looks like this component is trying to, separate the whole input text into the even lines, odd lines. So you can check out those outputs. And all metadata are stored on the metadata store. You can check out easily check out the metadata stores. And there are some more interesting maybe to try out the lineage explorer. For example, this key I could to maybe this one model. So by choosing one of those artifacts like a model, you can open the lineage explorer user interface. So where you can check out all the lineage. By lineage, I mean to reproduce this model, what are the conditions, like what data sets, what versions of the data sets you have used for training this model? What was the code to transform the data into the features and so on. And if you check out any other components, you can easily move the focus into those components. And I think there's some other interesting functionalities, executions, maybe artifacts. This training. what I want to show is the integration of the TFDB data validation with the Kubeflow pipeline. So I have shown the TensorFlow data validation demonstration video a while ago, and actually you can integrate that user interface into this Kubeflow pipelines integration. So you can easily check out the result. It's not this one. This one just shows the some ROC curve. Yeah, you can check out the ROC curve or some other visualization of the accuracy on the user interface. What I want to show is the iris. I don't know what experiments. Maybe this is it. Statistic gain visualizations. Or maybe it is. It takes sometimes for generating the TFDB output. So, but anyway, the thing is that now it's now you get the outputs from the TensorFlow data validation. The thing is that you can integrate everything into the single pipeline, like checking the data validation result, or checking the model validation result, checking the ROC curve, and so on. And so in a single console, integrated console, and anyone can take a look at that. Data scientist, ops engineer, or business stakeholders can share the same console, and everything is reproduced and tracked and audited. Okay, so that was the pipelines, and what are the upcoming products? So now the Air Platform pipeline is running on the GKE, the Kubernetes engine, and that uses some virtual machines. So you have to have some virtual machine servers up and running, and that is not so lightweight. So in coming May, we'll be launching a new Air Platform pipelines with the managed environment. That is a serverless environment. So you don't have to set up your own Kubernetes engines. Instead, you can just click some buttons, so you can get some serverless instances, and those instances would be stopped automatically. So you don't have to think about those virtual machines anymore. And it could be much inexpensive compared to the hosted version. So those are the benefits of the managed pipeline. No infrastructure required. It's a serverless pipeline system. And another new feature, new functionality is a feature store. Feature store is a data store for the features. Well, sometimes the management or governance on the feature data could be cause for the training serving queue. For example, data scientists would be doing some pre-processing or feature engineering to extract the very healthy, clean features and train the model. But if you pass that result to the ops engineers, sometimes ops engineer would implement the feature engineering or pre-processing in another way, maybe scalable way. But those slightest changes could cause the dropping down of the accuracy in the production system, training service queue. So to avoid that, we recommend to introduce a rule for sharing those features from the experiments, development, and production, shared in some central repository. So feature store is central repository for that. And also feature store provides some metadata management. So everyone check out some manifesto information of each features. So even though you have some data or features on the databases, nobody knows who made it or who has been or will be maintaining the features or data for how many months or how many years. So for building a production system, having just a raw data or raw feature is not enough. You have to have some governance, or you have to understand who are making each data and how many years those features will be continuously produced and updated and cleaned up. So that's the hardest part of building the confectionery factory for the enterprises. So features store is one component for that. Sharing the features and applying some governance on the feature, which is one of the most important aspects for the enterprises. In some cases, the feature store can manage the rich data such as the embeddings. So some companies like Spotify is now starting to share the embeddings instead of the features. The features are just features extracted from the raw data. But if you apply some deep learning model, any machine learning models, that model converts those features into the some other vectors. The vectors that has much closer semantics to the business requirements. Like in Spotify's cases, they are applying some deep learning model for extracting some the features such as what kind of the music each track is, what is the category, or like what is the tempo, or what is the I don't know taste of the music. So anyway, those features are represented in the embeddings, and some companies are starting to share those embeddings into some shared data store. So feature store could be used for the embeddings, used as the embedding store as well. And model monitoring is the next important functionality. This also will be launched in this May. So this brings the practice of the TensorFlow validation into the pipeline. So any SKUs are detected by TensorFlow validations on the serving part, then the SKUs will be visualized and shown on the console graphics. So that was it. So if you are interested in those products, please take a look at the pages. You can just go to the cloud.google.com, so you can access to all the resources I have explained. So that's it. Any questions?
Thank you. Thank you so much, Kaz. Yeah, I would like to open the opportunity for anyone here who would have any discussion or question or comment to the presentation. We got a number of people here: Daniel, Chinita, Pradeep, Ruben, Ucho, Reska, Jos. Do you have any question? If you have, just shoot it, just tell Kaz Sato. Don't be shy. Anyone?
Kaz, thank you very much for the presentation. I have a question about the managed service. So for the managed service, you say it's still in beta or trial. Is it correct?
Yeah, it's AI platform pipeline hosted version is now, I think it's GA. But some of the products I have mentioned, like managed the pipelines or the feature store, those products are still beta or maybe preview yet, and those will be published launched this May.
So far, from your experience, what is the main challenge in having this managed service compared to the other one, the hosted one?
Now, what is the main challenge to what?
The main challenge of the managed services compared to the hosted one.
On-premise to hosted one?
Yeah, so basically, because this is still in preview beta, of course, there are so many challenges that this service is actually having. From your experience, what is the main one?
The difference between the betas and the GA. That is the question, maybe. Yeah, because sometimes for some products like these products, the requirements from the Google Cloud customers are not well defined yet. because here we are bringing the new practices like model monitoring or continuous training. Those are quite new practices for some customers. So even for the customers or even for us, the product definition is not well defined yet. So the better version is to define those requirements. So based on the feedbacks we get during the beta release, we'll be defining the final product specifications at the time of GA.
Okay. Okay. Thank you, Kaz.
Thank you.
Yes, I think there are some people here that are quite new with this topic. So do you have any situation or like what do they need to do, like if they want to go into this topic deeper, or is it like we just go straight away to the website where we can find all this information that you give, or is there any preparation or anything that they need to learn in advance to really understand all this advanced information?
Yeah, maybe the first step is to go to the cloud.google.com and search this MLOps so that you can find the MLOps solution page. Yeah, I can just do that here, cloud.google.com. And there's a great solution page for MLOps. So you can find some pages and maybe you can check out the first one. Yeah, this documentation is written by a solution team that describes the actual, the example how you can combine those different components to build an MLOps system by yourself. So this could be a good reading for you for the first time. Yeah.
And is there any like a hands-on thing that the people needs to do, like to make this one really like something that like their skills?
What is your question again?
So is there any practice or something that they can learn?
Yeah. So this solution paper contains many practices, practice and learnings and rules for bringing the MLOps yeah, to your environment. Yeah.
Cool. Well, thank you. Is there anyone else wants to have a question to Kaz?
Yeah, can I ask a question?
Sure.
So my understanding is that like DevOps is not really a skill set that a lot of data scientists have, or they don't learn about if they're not coming from that sort of software engineering background. With the rise of this MLOps and data scientists having to be more interested in sort of the production systems and continuous monitoring, things like that, do you think that sort of those skill sets are going to become more important for data scientists to know, or is it going to more be this separate role that is further down the value chain?
Yeah, that's a great question, and it's depending on each team. And at Google, because we are hiring people who understand both of them, data science and basically, if you want to be some engineer at Google, you have to be going through all the coding interviews. So at Google, it's very easy to have the some people who understand both data science and infrastructure or ops. But in some other companies, some companies are using MLOps for having a different roles and different responsibility into different roles. Like a data scientist can be focusing only on designing a model and share that on the MLOps platform. And whereas the ops engineer or MLOps engineer or ML engineer could be responsible for bringing that model into production with the ML setup. So it's totally depending on the team culture or the organization of your company.
Yep, cool. Thanks.
That's cool, Daniel. Yeah, I think that's also a lot of questions that we we are asking as well, right? Like, because right now it's like two different thing. Right now, like everything is merged into like one thing. So yeah, that's really valid.
Yeah, I think I see it because like a lot
Thank
of
you.
data scientists that I talk to, they write really poor code and then they sort of handball it across the fence to someone like in an IT team who doesn't have the data science knowledge
Yeah.
about a lot of the things you covered about, you know, feature engineering, things like that. And then all of a sudden they're expected to manage a model and the data scientist doesn't really care about that sort of production side where, you know, is the model performing or not? Well, it performed on my desktop, so why do I have to worry about it anymore? That's someone else's problem. Sort of thing. So trying to bridge the
Yeah.
gap between those sort of two and bringing data scientists later in the journey as well, and then bringing IT in early as well.
Yeah, I guess everyone needs to be a unicorn then.
Ideally, but you know, finding that balance when that's not possible.
Right.
Well, it's 9 o'clock now, or whatever time now is. I think 10 o'clock, right? Like Kaz, for you, it's quite late.
Yeah, it's 10 o'clock here.
Yeah. Well, thank you, everyone. This is a really good discussion and a very good presentation from Kaz. Really hope that it will be something that will be really useful and inspiring for all of us. At least myself, it's very inspiring for me. And I believe that many of us learn something, at least one. Okay, well, thank you, Kaz. We're gonna put this online, and everybody who missed something can watch again, like the video. Okay,
Yeah,
thank you,
for
everyone. Good night. Yeah,
Thank you,
Kaz.
Kaz, for
Yeah.
coming. Thank you, Daniel. Thank you, Eunice.
Okay.
Thank you, everyone else. Have a good
Okay.
night.
Have a